Andrea Martinello, founder of Florence Next, the company that sponsors the event. And I've been working with MuleSoft for so many years now, too many to count. I would say roughly 10. Our company has a vertical, and is vertical in MuleSoft and Salesforce. And we have offices in Stockholm and in Turin. And today we are here, and I'm happy to see so many faces after pandemic, because it was like very difficult to gather people again in a room, and even not possible. So thank you everyone for being here, and thank you for the remote attendees as well. So our aim with this event is, to share practical and hands-on experience gathered on project and clients that we work on, and basically it's good to share among all the community of developer and system integrator. So the aim also of this event is, to do a well-blended event together with MuleSoft, and so thank you, Edward, for joining us as a speaker. And the overall topic today is API monitoring and Healthcheck. And then I will just, leave the word to the presenter. So Soha Torki from Florence Next will be the first. So I guess I'll just going to stop the camera and share the first deck of slides. Start. All right.
Okay, it's fine.
No, not in the...
No? Non si vede? Oppa.
Okay. Hello, everyone. Good afternoon. Thank you for being here today. I also welcome those who have joined us virtually. I'm Soha, integration specialist from Florence Next, and today it's my pleasure to be here to represent our Healthcheck connector. Briefly talk about the connector, then the API Healthcheck, and finally introducing our Healthcheck connector, concluding with a demo. So what's connector? As you all know, connector brings the new target system to the Mule runtime. It provides reusability by reducing the development cost and effort. And when you publish your connector, anyone can use it. It brings you the consistency. MuleSoft has around 250 different out-of-box connectors. They have also different support categories like Select, which is available to anyone with the Anypoint platform subscription. The premium connector is available only to the licensed user. And the support for the certified connector is through the MuleSoft partners who have created the connector. And the customer support for community connector is for the licensed component of the platform. Our connector is a private one, actually. It's but licensed under GNU, General License Public, about which I will talk later. But MuleSoft provides us with two options by which we can create our own custom connector. These are the XML and Java SDK. We are not talking about the SDKs here, but just to sum up, XML SDK is easier, it's simpler, it's faster to develop, but it has fewer features. On the other hand, we have the Java SDK, which is feature-rich and advanced, but it's more complex and it's more development time and knowledge, of course. So it's up to you which one to choose based on your requirements. So now let's see what is API Healthcheck. API Healthcheck is a common monitoring pattern for microservices architecture. It validates the status of the microservice. It returns the operational status of the API and its dependent services by checking the API for its availability, functionality, and performance metrics. It's in fact a diagnostic tool that alerts when something is wrong with the API, and it can be applied by implementing the endpoint, dedicated endpoint for the health check. Here, by this heartbeat, that heartbeat returns us the status of the API itself. But when we talk about health check, we mean the status of the API and its dependencies. But what is this API health check in a microservice architecture like API-led connectivity in MuleSoft? Here in view, and as you can see by calling the health check endpoint of your experience API, what the health check does, or in this specific case, the is to bring up the status of the experience, the process, plus the system. If you call the process, it includes the status of the process plus the system. And by the status of the system, we mean the status of the system plus all external services. So in order to achieve this, at Florence Next decided to develop a connector, a Java SDK-based connector to monitor our API for the health check. The connector has an important feature, which is reusing the existing connections, so you don't need to create more connections and configurations for this connector. Here we have a list of operations, and there's also a scope about which I will talk later. We have an operation which is internal services. It checks the status inside API-led connectivity layers APIs. Instead, for the external systems like HTTP, DB, JMS, and AMQP, we have dedicated specific operations here. Before going to the operations, let's just see the general structure response object of this connector. It has different fields like the name, the type of the API, the status, which is the most important field for us, could be healthy or unhealthy, response time, and an array of dependencies. Dependency simply means the dependent API system. And we have also dependencies errors array, which includes the errors of the dependencies. Now let's see some of the operations. The first one is create health check object. This operation is generally used with other operations to aggregate some result for us. It can be customized through this dependencies input parameter, by which you can create some specific result. Here, it also can be used alone in order to return us the heartbeat or the liveness of the system. Here you can see that there is no other operation. We are just using the object, and it returns us only the type and status, which is the heartbeat of the system. The next operation is HTTP, which is used to return the status of a system through HTTP request. By using the HTTP as input parameters, you can select the method type, which could be get, head, or post, of course, without body, the path, and URI and query parameters. The important point here is the HTTP module configuration. As you can see, there is no need to create the configuration. It's just enough to pass the name of the existing configuration here. And then, as I mentioned earlier, this health check object operation is combined with other operations. So now use this after the HTTP and dependencies input parameter, we pass the payload so that prints for us the whole response object. If you don't use this create health check object, it will just print you the status of the external system. The next operation is JMS parameter. We have here only the test queue. You have to pass only the name of the test queue, and again the configuration is the existing JMS configuration, and also the name of the service that you can choose, and the rest is the same as before. The create health check object to return the response. Also with the transform message, we output the JSON. Now we have seen some of the internal services operation, which is used to return the status of the inside API-led connectivity APIs. So here, for example, in the process, we have two different system API. So in the internal services tab, configuration module of this operation, we enter the name of our system APIs module configuration. Still, these are the existing one. You don't need to create them. And the health check pass, in case you want to change it. Okay. It returns us the status of the whole system. But here we have another operation, another parameter, optional parameter, which is custom mapping. If you enable it, it to extract the response object from a specific response. What does that mean? For example, here is the, and you put the response object under a data field or any other convention of your responses. In this case, for printing the complete response of the connector, you have to pass the payload data inside the custom mapping field in order to extract the correct health check response from the response we have. We have seen some of the operations. We have also a scope. A scope is similar to operations, but its execution includes the execution of the inner child. In case there is no specific operation for the component that you have, you can put that component like the consume for sub-web services operation inside the scope. And again, with the create health check object, it returns you the response. We have seen some of the operations. Now you may ask what is beneath this connector, especially for those of you who want to know more about the technical aspect. The core implementation logic of this connector is based on two interfaces. One is extensions client, which is used to execute operations for extensions. And another one is operation parameter, which is for parameters that are aimed to be used to execute an operations client. To make it more clear, for example, for the HTTP case, the parameters are being passed to the operation parameters, like pass the method, the headers, query, and URL parameter, and also the configuration name that we had. And then with the execute method of the extensions client, the HTTP executed. So this logic is used most in all the operations of this connector. So now to complete and conclude our monitoring, we can leverage this connector in any point monitoring, like creating a monitor on your health check endpoint and a session on the status feed to be healthy. And then creating, you can periodically check your API, and in case of any error, you will receive the notification. How you can use this connector? By referring to our GitHub repo. We can download it, install it. Just pay attention to add the dependency file. But I kindly suggest you to refer to the GitHub repo because there are more materials than what we have talked here. There is a detailed guide about all the operations, description, and also some other materials for the RAM fragment in case you want to create your branch. Send us the pull request, and we'll be happy for your contribution and collaborations. Now, to make everything more visualized, we can see a demo. For this case, we have an experience API, which has a process API, and the process has API. Next Chuck Dev, which calls an external service Chuck Norris through HTTP, and Systemo, which has three external services, the database, JMS, and again calling a cat facts external system through HTTP. Okay, now in the system layer, I use the create health check object just to return us the heartbeat of the system. In the heartbeat endpoint, we pass the name of the API, the type, which is SAPI here, and there's nothing left. As I said, for the heartbeat, you don't need to pass any dependency. It can be null, and that's for the heartbeat. Output JSON. There's also an embedded module. You can see this on the repo. Instead, for the health check, we saw that we had three different systems: the database, the JMS, and HTTP. The database gets the select query in order to get connection for the database. Again, you see that the configuration is already we have. We can create this again. And also the JMS configuration and HTTP configuration are all exist. For the JMS, we enter the name of the test queue and the JMS configuration. For the HTTP, we set the path of that cat facts, which is facts random. The method, as I said, could get head and post. And here, there's no other parameter. So here we have three with the scatter gather. So pay attention that for create healthcheck object, we should pass the correct payload as the dependent. Now go to our process. It is the same, but for internal services, because we are in the process, we want to check the systems. So we name the type, and in internal services tab, we pass the name of our two systems, which was Next Chapter Dev and the SAPI demo. Again, configurations are the existing configurations, HTTP configurations here. Create healthcheck object as before, and the transform message. The experience is the same as process, except here we have only a process as internal services. Create healthcheck object as before, and now we call the experience layer healthcheck endpoint to see how all the APIs. So you see that the experience is healthy because its process is healthy, and process is healthy because the two system layers, system APIs are healthy. The next chunk is calling the external system, which is healthy. And the system had three different dependencies: the database, the JMS, and the random fact. All three are healthy, so that's why we have the process and experience the healthy status. But since in real case, always like this, and we may have errors. Now we see the next, why it's not being played. Okay, here, in order to make you see some errors, I changed the credentials of database with the wrong one. For example, I entered the wrong username here. For the HTTP, I changed the path with the wrong one. I cut some characters. And the process system, we go to the process, and we had two system API process. One of them was Next Chalk, which was on CloudUp, and I stopped the API from CloudUp. In this case, we go and call the healthcheck of the process layer to see how is the status. And as you can see, the process is unhealthy because the receive timeout error is unhealthy, and the system demo, we had three different external systems or three. Database is unhealthy with connectivity error, access denied for the wrong user. The JMS was healthy, but the HTTP, again, I changed the wrong path, so we have the bad request error here. And the dependencies errors contains both errors of the system layer in one. Also, for the process, we have a dependencies error array, which contains all the errors of dependent APIs. Okay, to wrap up what we said, Health Connector, we saw that provides a reusable, fast monitoring method for us. This production ready is actually now being used in production for our customer. And as future work, we will keep maintaining Connector, and we want to add some more operations to be developed, especially for some common cases that we need. Thank you for your attention. In case you have any question, please let us know.
Is there any question? Maybe do you have any question on the?
I think we could.
Yeah.
I'm just thinking in terms of time. If you can answer the questions on there, and then if everybody else can wait with the questions. And then I think what we'll do is, I think we should grab our lunches now, and you guys eat your lunches while I talk. So we have, there's but there's also vegetarian salad. So for the real vegetarians, make sure you grab the vegetarian one. Otherwise, just choose what you want. Okay.
Yes, I think. Thank you. So it was amazing.
Okay. So now we are grabbing lunches and switching the presenter. So
Yeah.
that's fine. Good.
Okay. And I'm the presenter now. So.
So you need to.
Oh yeah. Okay.
Yes.
From the platform.
Oh yeah. Okay.
Go to the
Got it.
share screen and share your slide or your screen, whatever.
Right, just do the whole. I went through the whole window.
Entire
Window.
screen.
Entire screen's fine.
Okay.
What the heck happened to my? Yeah. So if you guys don't mind, I'm going to start talking while you're eating. So just and be a little informalized. So thank you all for being here. This is awesome that you all showed up. And can you guys hear me? Can they hear me online?
I think so.
Okay. So today I'm going to talk about, we have a universal API management solution now. I don't know if you guys are all familiar with that, but I'm going to talk to you about what's the idea with it, and then we're going to just go into deployment models of that. So different ways to deploy it, different alternatives, and then I'm going to finish off with showing you some of those ways that I tried to deploy in certain senses, and other ways where I actually deployed it. Okay, and then how you can apply policies and everything. Sound good? First of all, the Anypoint platform now supports the Flex Gateway. As you know, we come from the classic gateway where we just exposed our from the runtime manager. We took our applications and we exposed them with the classic gateway as its own gateway. Now we have actually a proxy or a new gateway that's built on Envoy, and that is very flexible, therefore called the Flex Gateway, and you can deploy it on multiple different platforms. The first one, of course, is just as a Linux service. So just take a VM or anything else and throw it on there, and then you can use the full system for that. The other is having multiple containers on any sort of Linux machine or any other machine. That can be Docker containers or any other type of containers. And then, of course, in terms of when we talk about meshes and east-west communication, then we can also have sidecars. So the Flex Gateway can act as a sidecar and actually control the traffic between, for instance, microservices components. So, but that's a one-to-one, and I'll get into that. And the last one, of course, is the Ingress controller, which we assume that the majority of people will run, where they're basically just monitoring and putting on policies and monitoring the connectivity to the Ingress controller that are deployed. Here's some examples. As a sidecar, of course, that's a one Flex Gateway per application, because that's what a sidecar does. It's a one instance thing, and it controls east to west communication. We also, from MuleSoft, have the AnyPoint service mesh capability that allows you to take your service mesh and plug in the adapter and then get your APIs into the platform. Okay. So I'm going to get into the service mesh and the east-west communication. There's also on its own pod, standalone, that can also be naturally, this is in Kubernetes, but it says deployment topology suited for east-west communication, but I wouldn't consider that the best option to monitor communication between every single application. So, but that's more of an opinion. And then, of course, as an Ingress, which means that if the gateways are deployed separate under pods in different namespaces with separate allocated resources. We're going to touch upon shared resources in an Ingress controller, for instance, in terms of a Redis database or caching. Okay. Okay, so what can be protected? We have the north-south protection, and we have the east-west protection. And this is where we have the AnyPoint service mesh currently, where we or adapter that we can expose the services in a service mesh to the platform. So normally when people talk about gateways, they talk about north-south protection, and they talk about Istio service meshes or service meshes for east-west communication. The important thing here is the Flex Gateway is built upon Envoy, the Envoy proxy, which many gateways are built upon. And FluentBit is also a part of that in terms of external logging. It's a very good gateway. I think it was Link who invented it, but many proprietary gateways are using that underlying technology. And of course, you can set any policy in terms of rate limiting, authentication, caching, all these things. And we're now also introducing new support the entire time. So we do have, under the Garden agreement, we also have gRPC support coming in and these kind of things. So we have a lot in the roadmap. Okay, so when you're running the Flex Gateway, you can run it in local mode, or you can also run it in connected mode. Connected mode simply means that I'm going to show you the connected mode today. The local mode is more if you don't want constant contact with the control plane. You can still, you still have to register the local mode, but then basically you do your entire configuration from YAML files. So an example of a high-level architecture. It's kind of going off the screen here, but basically in Azure APIM, they have a gateway there, and then we could put the Flex Gateway there as opposed to that, and we can put it in all these different areas, either as Ingress controllers or as pure gateways. And all these Flex Gateways will have access to the control plane, and from there you'll monitor your gateways and you'll monitor the APIs under the gateways that are deployed, and then you can apply policies just like you can on the classic gateway, where you can apply policies either as automated policies for the environment, or you can apply policies as for API groups, or you can apply policies, of course, per API. And I'm going to show you some of the policies and how to apply this. This is actually taken from a customer. It was our example of what they have now with the Flex Gateway. Okay. So when we talk about the most common deployment model will likely be, so I don't know if you guys have noticed, but MuleSoft is moving all their deployment models to kind of a standard deployment model based on Kubernetes. Okay, so Cloud Hub 2.0, RTF, BYOK, and of course even our OpenShift solutions. We're all gonna synchronize those around one common model so that we only have support that common model. Before we had to support RTF appliance, Cloud Hub, and these are all in the background running on different technologies and different models. So we're streamlining all those models. When it comes to the Flex Gateway will most likely be, or most commonly be deployed as some sort of Docker image or a container in Kubernetes. So therefore, we're going to talk a little bit about Ingress gateways, because Ingress gateways, as you know now, if you're familiar with it, they're kind of the modern for both microservices architectures, service meshes, internal east-west communication, but also externally. So what we do is plug ourselves into the Ingress gateway so that we can put policies on those APIs whose communication is being decided in the Ingress gateway, right? And here is just an example of how you do that. This, for example, is adding Redis, which we'll get into earlier, but it's just adding persistency to the gateway into this communication. So finally, there's the service meshes, which is the communication which we call east-west communication. And there's a lot of service meshes. There's Istio service mesh and so on. The solution with the Flex Gateway is to not only take care of the north-south communication as a gateway, but also to take care of the east-west communication. So if we look here, we have an example of the booking service, an inventory service, and shipping service. This communication is done internally, for instance, on a pod. And then we need to come in to that booking service externally to activate it. And that would be the gateway aspect, okay? So you can put the Flex Gateway, if it's an Ingress controller, you can actually have the Ingress controller that monitors, it'll monitor the north-south or coming into this, but then the east-west communication will be through this service mesh, monitored through the service mesh, what we call the, yeah. And so what we do is, in this particular example, we have 3 services or 3 microservices, and we are opening up these 3 microservices externally by adding a gateway, in this case, an Ingress gateway. So, and what we want to do is that we will push in the Flex Gateway where this Ingress, instead of using the Ingress gateway, we'll push the Flex Gateway in. And then we can maintain north-south or communication coming into this service mesh. We can put proxies on it, we can rate limit and monitor it. The next step is we can also, between the services, which is now historically a service mesh, this is the east-west communication. We can also monitor that, but we would do that in a sidecar fashion or with the Anypoint service mesh plugin. So we would plug in on your Istio, on your current service mesh, we would push in the Flex or the Anypoint service mesh plugin, and that would send information back to the control plane from within this mesh. And if we do that, we don't even have to use the Flex Gateway if we have the service mesh component, because then we can monitor and put policies in between these two and rate limit in between these services. So when we're talking about communication and these things, it's important to look at it northwest, north, south, east, west. And every time you talk east, west, you talk within the services and within the microservices teams. So just important to note, it's not any traffic outside the mesh is not permitted by default. Therefore, we use gateways and we use Nginx, and we use these different technologies to expose, for instance, some of these services outward. Okay. So I don't know how many people work with service meshes and gateways. Do you guys have is this okay? 2. They're the ones who told me to do it. That's why this. Okay. Well, you'll get into it if you're not using it now. So, all right. So on that, I'm going to show you some of the deployment options. So we have these different deployment options. So I'm just going to walk through these and show you kind of, in a demo and what I played around. And I actually played around and tried to create an Ingress controller. And that's a mistake I won't do again without access. But the other examples I can talk through and show you. Okay. So if we look, first of all, we're in the platform. And are you looking at the chat? So in case there's anything wrong with it.
Yeah.
Oh, good. Okay.
Yeah.
So we're looking at the platform, and then you're all familiar with this. I have a let's see. Let me go into my. I have a few different, as you see here, are my attempts at creating multiple gateways. One problem is that when you create a gateway, because of course I'm playing around now, but every time you create a gateway, it takes 30 days for it to be deleted or taken away from your screen. So we're working on that. So it's kind of annoying to see all your messed up attempts. But here I have one gateway that's based on just a Linux, a core Linux install. This one is an Ubuntu that I've tested to also use as a Ingress controller. And this one is the one I didn't succeed with, which was my Kubernetes instance. But I still managed to connect it. So when you do this, you come in, first of all, to add the Flex gateway, you choose where you want it to run and what platform it's on. And as I mentioned, this Kubernetes, Docker, and OpenShift, these are the same to us because now we're running the same model, okay? So if we're on Kubernetes, then you would, do Docker pull onto your instance. Then you would run and register and run your Docker image. And then you would add the Helm chart. So this is, okay, I'm going complicated first, so let's go easy first. If we just take one container as opposed to Kubernetes, which is maintaining multiple containers, then you would pull the Docker image onto your machine. You would run the registration, and that would create this registration XML file. And then you would start it on port 8081 because the Docker image is going to be started on 8081. You can then create multiple replicas of that. So you can have one running on 8081, another running on 8080. But these are different containers that you'll see are running. So if we go back and we have a look at some of the containers, I have, like, for instance, created multiple containers here. Now, when you put this in an Ingress controller, then you'll put the replica set. So the replica set will say how many, when Kubernetes will actually, since it's an orchestrator for containers, you will actually define, I want 4 replica sets all the time for this Kubernetes instance. And it'll automatically create them, and you'll see them here. Okay, so this is every replica that you have of this service. The other thing is, you can create them manually by just creating different Docker containers on different ports, or you can use Kubernetes to do it. What you want to do, though, is when you have a Flex Gateway registered, I can actually show you that. Let's see. Where am I? Nope, not there yet. If you have a Flex Gateway registered, let me see. Everybody see my screen, I think. So in this, I have my Docker images, and then this is the EC2 instance where I've installed a Flex Gateway, and I have my mini cube, or my fake Kubernetes, or my Kubernetes for one node here. And then I have actually created 2 gateways here. And then I have just an application that's running that I want to. The application can be running anywhere because the Flex Gateway can, you take that as the source. But I only have so many machines, so I put that application on the same machine. What I'm going to do is I'm going to call that application through the Flex Gateway, because then we can put policies on it. All right. So let me just see. This is my other machine where I have actually the Flex Gateway running on the core Linux. So the core Linux machine. So, and then here I actually have quite a few different images running. That's my.
I wonder if you can zoom it a little bit.
Oh, yeah. No, it's not working too much. Is that better? Or?
I think it's Command plus.
Yeah, just sorry about that. Yeah, let me see if I have that. So this says Docker run 3000 IT Mule Thunder. This is the application that I just started here that we're going to proxy to. Okay, so if we go in and we set up this API. So as you know, we have multiple APIs in the platform, and I'm going to take this API, which is actually if you guys are familiar with Beyond framework, it's a Beyond API. That's an open API that I've taken in, and I've just wrapped it, okay? And when I wrap that API, then I want to expose it, and then I'm going to call it through the Flex Gateway. So this Beyond exec payment has been wrapped. So here, if we go into the Ubuntu one, my Ubuntu instance, my Flex Gateway, and I can go to that application. And then I actually put the consuming endpoint of that app. That app can, as I said, it can be anywhere. The important thing is that anybody who's going towards it, this is where it's running. This is the implementation URI. And everybody that's going to hit it is going to hit it through the consumer endpoint. And that's what we're going to protect. Okay. So if we look at, let's have a look at the consumer endpoint. And it says resource not found because I don't have the full, sorry. It should look like this. And then it just gives me the format, the Beyond format through the gateway because I'm running through 8081 now because I've deployed that. So this is actually functioning, and then I get logs and I get information here. I can see how many times it's been called and the response times, all the monitoring. But what I would really want to do is put policies on this. And of course, you can put automated policies, which are the same as the policies per API. But in this case, I have a message logging policy, so I can get the information. And of course, I'm not even going to do that because I tried that yesterday, and I have to get a new token from OpenID. So let's not do that now. Let's add another policy. So there's another, well, this should actually complain now if we can refresh it. Come on. Yeah, so access token wasn't provided because I require the access token now. This needs to be refreshed because I enabled the policy for OpenID Connect. So that's just an example about how quickly the policy, when you set it, how quickly it's activated. So this, as I mentioned, this service on the endpoint, it's running in Cloud Hub, okay? So this is my EC2 Cloud Hub instance. That's the backend. And I'm now reaching it through my Flex Gateway. And I applied a policy and the token was not provided. And that goes for any policy that you want to apply. There's tons of policies. You have caching, spike control, rate limiting, and so on, cross-origin squaring. And then, of course, the rate limiting is one that you would want for your communication. And when I'm showing you this, of course, I'm showing you this is the east. This doesn't matter if it's north, south, or east, west. The important thing is that you have the API in Exchange. It's checked into Exchange, and then you could apply the gateway or put it under the gateway so you can protect it. Okay. So that was one example. The other example I have is this payment proxy. Let me see where this is now. This is on my other machine. Okay, it's kind of died right now. Oh, they both died. Sweet. Here. Back to Runtime Manager. Back to my Flex Gateway. And my list connected. So this is the one with the Linux, and this is the one that's running the duplicated containers. Let's see, I have, and that's the Beyond Test one I showed you. And I'm going to go back and show you the one that I have on the Linux machine. And that is this API, a proxy. So just to show you, I wanted to show you also when you add an API, it's you simply choose which runtime. This is the classic Mule gateway. This is the service mesh that I was talking about. But you come in here and you choose which Flex Gateway it is that you want to push it to. And then you choose, either you can create a new API and take the specification and push it in, and then just make sure that you have the URI, the implementation URI and the consumer URI. The consumer URI will be from the Flex Gateway. So it's really easy just to push, for instance, something in here, call it an HTTP API, and then you can upload it. Okay, that's what I've done with this API, and now I have it uploaded, so I can go in and my pay proxy, and then I can choose and go next, and then it'll create that for me, and then it'll deploy it. Okay, so that's basically what I've done. And if I go back, and once you've deployed it, then you get something like this. And let's see if this is my functioning one. It's not my functioning one. Interesting. Let's see where I put that. Well, let's make it function. So this is the actual application that's running. That should work. Not. I think all my sessions went dead. Let's try that again. So let's see where that went. Policies. Pay proxy. See, yeah, created another one. Great. So yeah, so unfortunately I have to fix that because it doesn't seem to be, come on. So that's my endpoint that I want to protect. And I had protected it, but now it doesn't, there it is, because that's my, so now we want to protect this because now it's going through the gateway. Now we want to protect this. So we can basically put add policy and add any sort of policy to it. So kind of running short on time, but that was a quick walkthrough in the Flex Gateway and the different deployment models. Let me see if I have a showing there. Oh yeah, sorry, this died, this window. Let's try it again. So as I said, these are two container images that I have. Ideally, these containers would be taken care of by this Minikube or the Kubernetes cluster as an Ingress controller. That's what I was trying to set up. But now instead I have two replicated containers that I'm pushing policies to and updating. And over here, of course, I have the, yeah, I don't have anything. I just have the Flex Gateway on the actual hard drive running on the actual VM. And that's the second one I showed you with going through that and applying proxies on this one. Okay. And the first one was this the Beyond one that I showed you. This one here, wait, there we go. There it is. So this was going through the other machine where it's just a flat gateway. And this is the API that I wrapped basically, and then I exposed it, and then I reached it through the gateway. So that's just some quick examples of the gateway and how to do it, and a talk about the north-south protection and the east-west protection and how we do it. The idea is, as this is a developer meetup, that you guys then will play with it and play with the different scenarios. It's actually really easy as long as you have access to a Kubernetes cluster. Okay, I learned that the hard way. So you can also, I did put some energy in trying to create a Minikube and doing this, and I was halfway there, and then finally I decided to have dinner instead, so I gave that up. But you can also use Minikube. You can push that in and create your own kubectl and Minikube and an Ingress controller off of that. That works just fine. It's just I'm not competent enough to do it myself. So have fun, play with it, and I'll leave that to, yeah. You mean my machine or my face?
Up to you. Okay, there are a couple of questions, but I think we are really over time, so maybe Edward will take it. Can you answer?
Yeah, I think so.
Do you see there are a couple of them by Sudhir? So okay, and last part would be like our rolling wheel for free voucher certification. So we confirm the on-site people. So I will probably pronounce it very badly. So please bear with me with that. Ake Oberg. No. Andreas Timudas. Nice to meet you. Okay. Doug Zenitz. Nope, no Dougs. Emil is there. Often there, right? Shamila Keburu. Hello, nice to meet you. Sai Nikita. Hello, nice to meet you. Mikael Zulfings. Thank you. Christian Brendstorm. And Jasper Eriksson. Hello, nice to meet you. All right, so I have all the name. Okay. And can I have the thing?
Oh yeah, all yours.
C'era, se l'ho visto. Oh, all right. So I think we are in.
Sorry, I didn't get it. What are you saying?
It's a free certification voucher from MuleSoft.
All right.
Two of them. So Emmanuel Santoro. Oh. Sorry.
I was just gonna ask. You got the free lunch. So.
Okay, and okay, of course, Emmanuel won't win the second one, but I don't remove it. And we. Antonella Greco. Thank you very much. And our HR take care of. Just email the HR. Giulio, the moderator, is in the chat. So maybe have his email address. Please, maybe Giulio dump it into the chat, and then he will do the requesting for MuleSoft for the certification. Aside of that, I think thank you for our amazing speakers. Another big clap. Thank you very much. It was very interesting, and thank you for showing up. And happy to see you more often and do more of this, because I think it was a very good event. Thank you for coming.
I'm going to answer these questions. They're very big.
Yeah.
So, but did everybody get? Oh, there's some left. Okay. You guys went through each